Hello everyone. This work presents TrueLearn, a family of Bayesian algorithms to match lifelong learners to open educational resources. This paper was presented in AAAI conference in 2020 and involves developing an online learning algorithm that can predict engagement of informal learners with educational videos. Literature in educational data mining and learning analytics communities propose that there are various factors that drive learner engagement. For example, the quality of educational materials, the learner's interests and learning goals, and specifically phenomena such as the presence of novelty or providing sensible learning trajectories are unique features that should be incorporated in educational recommendation systems. Taking these factors into account, we proposed a probabilistic graphical model that models the interplay between these factors in the same AAAI conference. And as you can see, this model takes into account the quality of materials, the background knowledge of the learner, the degree of novelty that is introduced to the learner, and also the learning interests and goals of the learner. The TrueLearn work, that is the focus of this talk, addresses two components of this main model, which is the background knowledge and novelty aspects of the learner. This figure demonstrates the assumptions that are portrayed by the TrueLearn novel probabilistic graphical model. When a learner L interacts with a resource R, we assume that the learner L possesses a certain degree of skill, which is theta L, and a resource presents a certain complexity or a topic depth, which is dr. And for the learner to interact successfully with the educational video, the learner's skill and the topic depth should align in a certain way. We take this assumption and create a probabilistic factor graph that demonstrates this phenomenon, where the learner's skill theta L is modeled as a Gaussian variable and the topic depth is presented as a Gaussian constant, and the interplay between these two components will learn and update the learner's skill over time. As you can see, the novelty component, which is this alignment between the skill and the depth, is used in the factor graph to drive the learning process. Once we constructed this model, we identified a video lectures dataset that we can use to evaluate the predictive performance of this probabilistic graphical model. We used the peak dataset, which comes from videolectures.net, a very popular video lectures repository. And the dataset that we incorporated or used contains learning sessions or video watching sessions from over 20,000 unique learners. With TrueLearn Novel, we also constructed a few competitive baseline models and compared the performance in order to do performance evaluation. Because this is a classification problem where the task is to predict if the user is going to interact with the next video fragment or not, we use classification metrics such as accuracy, precision, recall, and F1 to measure the predictive performance. And we use the F1 score, which is an aggregation of the precision and recall metrics, in order to do model selection. And our results with the peak dataset demonstrates that the TrueLearn novel model that we propose is superior and outperforms all the competitive baselines. In a deeper analysis, we compared the knowledge tracing model, which is one of the popular models used for similar tasks, with the TrueLearn novelty model to see how TrueLearn novelty model improves the predictive performance. Our observations pointed to the fact that TrueLearn novelty model performs much better in scenarios where the users have a wider range of topics in their user journey in comparison to the knowledge tracing model. Looking at the future, we see a lot of potential in incorporating reinforcement learning in the TrueLearn framework, given that TrueLearn framework is an online learning algorithm that works on sequences of interaction data. For example, one of the next steps for us would be to incorporate the other components, such as quality and interests of learners, in the overall engagement model. And this might lead to having multiple models that use these different aspects to predict engagement of the learner. Reinforcement learning is a great tool for us to use in order to combine these predictions together in order to make better ensemble predictions on engagement of learners. And also, we would like to incorporate TrueLearn algorithm in a real-world learning environment. And in such situations, we have a lot of potential in taking various different interaction methodologies that are available through the learning platform to provide signals to the TrueLearn model. And when doing this, reinforcement learning can play a huge role in terms of adaptively using these intelligent user interface components to provide different types of signals that the TrueLearn framework can use more effectively. Thank you very much for listening to our talk. And if you want to access the original paper, the QR code on the slide would allow you to get to the URL. If you need further details about this paper and our work, please do not hesitate to contact us. Thank you very much and have a good day.